A permutation is when things are arranged in a certain order. A combination is when things are not necessarily arranged in a certain order. The order doesn't matter. So for these two words, permutation and combination, you will hear me say, does order matter or does order not matter? You need to know the difference between these two words because it plays a big role in when we start to compute probabilities for permutations and combinations. So, things are arranged in a certain order for a permutation. Arranging the order in which you do things, like first I want to brush my teeth, then I want to blah, 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 your morning routine. That would be a permutation. Combinations, order of thing doesn't matter, so deciding which toppings you put on your sub at, not Sidekick anymore, CC's. It doesn't matter what order they put those toppings in or what order they put the toppings on your pizza, just as long as they're all on there. That's a combination.
I'd rather sausage.
In the end, though, it doesn't matter. It's all on there. Choosing 3 cities to travel to on a vacation. So maybe you want to go to London and Paris and Rome, and it makes no difference in which order you go to those 3 cities. However, the order in which people take first, second, and third place at the track meet this weekend, that does matter. The third place person would be probably pretty happy if everybody's like, who cares? Here's the first place trophy. So let's take a look at these 4 examples here and decide whether or not they're permutations or combinations. So choosing 6 students from a class of 25, permutation or combination? Like Mr. Flock walks in here and he says, I need 6 students, you, and you, and you. That's a combination. Doesn't matter what order he picks them. He's going to get 6 of them no matter what. Okay, the arrangement of the letters in school. Yeah, because if those letters were in any order you want, you wouldn't have school anymore. You'd have like Oshls or something. This is a permutation. Selecting 2 side dishes from a menu. Combination, yeah. Choosing 3 classes from a list to fill your first, second, and third periods. That's a permutation. The classes themselves are a combination, but as soon as you try to put them in first and second and third periods, that makes it a permutation. So there's one other thing I want to talk about here before we move on. There's something probably that is in your lives where you've used the word combination before. Is there any sort of thing or object? Like a locker combination, yeah. Let me ask you this. On a locker combination or on a combination lock, does order matter? If your locker combination is 32, 4, 16, does it matter in the order I put those? Can I go 4, 16, 32 if I want? No, I have to put them in the same order that is given to me, right? In order for that locker to open. So is that a permutation or a combination? It's a permutation. Order matters. That makes it a permutation. So actually, we use the wrong word when we say a combination lock, because it's not a combination that you're using. It's actually a permutation. They should be called permutation locks. That's true. The first of those 2 that we're going to deal with is the permutations case. To find the number of permutations of a scenario, use this formula right here. That needs to be memorized. Little n, capital P, little r. Those are both little and subscript. And then that equals, what does that say in the numerator? N factorial divided by, in parentheses, n minus r factorial. So now I got to tell you what those letters mean. N is the number of distinct objects. And r is the number of objects taken at a time. That's the vocabulary that is used for n and r. And the way you read that is npr equals n factorial divided by n minus r factorial. So, for example, there are 8 swimmers in a race. how many different ways can first, second, and third place be awarded? Well, does first, second, and third place, does order matter here? Yes, and that's something you always want to ask yourself. Does order matter? If it does, then you're working with a permutation. So that means we're going to use this formula, NPR. We have to figure out what N is and what R is. So this says N is the number of distinct objects. In this problem, that means the number of people in the race. So 8. We're using a permutation, and this number right here is 8. R is the number of objects that we are actually looking for. So since we're talking about just first, second, and third place, we're looking for 3 objects, first, second, and third place. So that's the notation that helps us figure out that. Now we can set that up. It's n factorial, so 8 factorial, divided by, in parentheses, n, which is 8, minus r, which is 3, whatever that is, factorial. That's the setup for the number of permutations, the number of ways that this specific situation can happen. So then you can type that straight into your calculator, or you can simplify this denominator down. 8 factorial divided by 5 factorial. And what is 8 factorial divided by 5 factorial? 336 ways. So with 8 swimmers in a race, or 8 runners in a track race, or 8 of anything, if I am going to select 3 things and put one in first place, one in second place, and then one in third place, there's 336 ways for that situation to happen, for just first, second, and third place. So that was how to do a permutation, just a standard permutation. If we have a permutation with repetition, there's another formula that we have to use. If you're working with a permutation that allows for repeats, so like in that swimming problem, there's no way that a swimmer can take first and second place, so there's no repeats on that one. But sometimes you can have situations that allow for repeats. So if you're working with a permutation, order matters, that allows for repeats, you need to account for those repeats. So the formula then switches to n factorial divided by p factorial, q factorial, and then there could be more even. P and q just represents the repeats and the number of times that each is repeated. So if I have something that's repeated, I'll divide by the number of times factorial that that thing is repeated. If I have 2 things that are repeated, then for that first thing that's repeated, I'll divide by the number of times factorial that it's repeated, times the number of times factorial that the second thing is repeated. If I had 3 things that were repeated, I'd have another one on there. That third thing, maybe it's repeated 4 times, so that would be a 4 factorial sitting there. Perfect example of this is how to find the number of different ways that you can rearrange the letters in the word Mississippi. Obviously, I can move the M and the I, and that would be 1 permutation. The word Mississippi itself would be 1 permutation. If I move the S out front, S-M-I-S-S, that would be a permutation. But if I swap this S and this S, will I know that I have done that? I wind up with the exact same arrangement of letters. Okay? So that is a repeat right there. If I swap this I and this I, will I have a new word? No. So that's what we're talking about here. I want to figure out how many ways I can rearrange those letters in that word, but I don't want to count the repeats more than once. Okay? So that's why we're using this formula right here. Now, N is just going to be the number of letters that we're talking about, the number of things that we're talking about here. So how many letters are there in the word Mississippi? How many letters are there total? There's 11. Yeah, N is 11, the number of letters total. So it's going to be N factorial, which is 11 factorial. Now divided by, we have to find the repeats. So does M repeat? No. Does I repeat? Yes. How many times does I repeat? How many times do we see the letter I in Mississippi? 4. So it's going to be 4 factorial there. Now we move on to the S. Does S repeat? Yeah. How many times do we see the letter S? 4. So we're going to need another 4 factorial. And then we've taken care of all those. What about P? Does P repeat? Yes. How many times do we see the letter P? 2. So we'll write 2 factorial. And that takes care of all of the repeats. Each one of those factorials in the denominator is something that's repeating. We write down how many times we see that thing. Now we can type that all into our calculator, and what do we get? No. Notice on your screen how that has not all wound up in the denominator. You need parentheses around the denominator so that it all stays there. 34,000 what? 650 ways. So we could sit there and come up with all 34,650 ways to rearrange the letters in Mississippi, and every single one of them will be unique. We won't have any repeated arrangements of letters. That's what that formula does for us. Otherwise, if we don't account for this repeated arrangement of letters, then we'll have a whole bunch that are just repeated, because I can swap this S and 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 this S, and each one of those would be a repeated, exactly the same looking result. And we want to exclude those. So that's why we use that formula. Okay, switching to combinations. What is the difference between combinations and permutations again? Right. Combinations order does not matter. Permutations are in order, some sort of specific order. So for combinations, the formula switches a little bit. Notice that now instead of NPR, it's NCR. Why is it C? Combinations. So that means that the capital P in the other one was for permutations. Yeah. So it's NCR this time. We still have the n factorial in the numerator. We're using this formula. We still have the n minus r factorial in the denominator. But now we're also multiplying by another r factorial. The n still represents the number of objects, and the r still represents the objects taken at a time. It's just that now order does not matter. So let's go to the snack machine, and we're going to pick 2 snacks from the snack machine, and that snack machine happens to have 10 types of snacks. Does order matter there? No, because if I get the goldfish and I get the granola bar, it doesn't matter if I get the goldfish first or the granola bar first. I'm still getting the same 2 things. So order does not matter, which means I'm using a combination. So we need NCR. What's N going to be here? N is 10, because it's the number of objects total that we're looking at. How many objects are we taking? 2. So it's 10C2. And now we can write our formula. N factorial, so 10 factorial divided by n minus r, so 10 minus 2 factorial. But then we need that extra r factorial, so 2 factorial also in the denominator. Type all that into your calculator, and what do you get? 45. 45 ways to choose 2 snacks from the snack machine. Is it smaller? Doesn't sound right?
There's 10 snacks you can get. Cheeses.
But there's 45 ways to choose 2 snacks.
Oh,
Okay, so yeah, you can get the Gordettos. Well, you can pick those first or second. So that adds to some possibilities. All right, so we'll put everything together here, determine whether the situation calls for a permutation or combination, and then answer the question. So our chemistry teacher divides her class into 8 groups. Each group submits 1 drawing of the molecular structure of water. She will select 4 of the drawings to display. And how many ways can she select the drawings? This is a combination, that's right. As long as the 4 are selected, it makes no difference in what order they're selected in. So we're dealing with a combination here. Now we want to figure out how many ways this situation can occur. So that means I'm using the combination formula. So I'm going to write C, and I got to figure out N and R. What's N?
8.
There are 8 groups. How many is she choosing? 4 of them. So it's 8C4. And now we can type that, or write that out. It's n factorial, so what do I write? 8 factorial divided by 8 minus 4 factorial times 4 factorial. And then we can enter that straight into our calculator. And what do we get? Yep, there's 70 ways. You will draw winners from a total of 25 tickets in a raffle. There's only 25 tickets in the raffle. Be a good raffle to be involved in. The first ticket wins $100. The second ticket wins $50. The third ticket wins $10. How many ways can you draw the 3 winning tickets? What is this? This is a permutation. 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 No. All right, so we know it's a permutation. What do we have to write now? Permutation formula. So I write the P, and then there's 25, and we're choosing 3 tickets. So the permutation formula then says factorial divided by factorial equals. Is that what you guys all got? 13,800 ways for you to draw 3 tickets in order out of a hat that has 25 tickets in it. Yeah, there's a lot of ways for that little drawing to go, even though it's only 25 tickets. It's worth talking about because this is not odds, right? This is not a probability here. This is just the number of ways that 3 tickets can be drawn in order out of a hat from 25 tickets. If I'm talking about probability, then I need wins over ways, which we're not doing here. But how many wins are there in this situation? 3. How many ways are there in this situation? 25. So the probability of winning in this raffle is actually 3 over 25. But there's 13,800 ways for those 3 tickets to be drawn out of the hat. So it's definitely a different thing that you're talking about there. That's how many ways there are. But there's a probability of 3 over 25. Yes, this ways is just the 13,800 ways that I can pull 3 names out of a hat. Yeah. But as far as probability goes, it's not this at all. It's 2 different things. Now, in a little bit, we will combine. I don't want to use combine. We will use probability and permutations and combinations together, and then you'll be able to see what it's like when you're working with permutations and combinations with probability. So this page is just practice. We have 3 problems for permutations and 3 problems for combinations to practice. The formulas are sitting up there at the top. So for 5p3, I'll just go ahead and do the first one. We have 5 factorial divided by 5 minus 3 factorial, so 2 factorial. 60? I believe you. Okay, I'll do that combination one below that. So this is a combination, which means I'm using this formula. So I'm going to go 4 factorial divided by 4 minus 2 factorial, which is 2 factorial. And then 2 factorial. Now, R is this number. Now notice that it's 2 factorial times 2 factorial. That does not mean 4 factorial on the bottom. No. 2 factorial times 2 factorial is not 4 factorial. You have to keep them separate. So we have 4 factorial on top divided by 2 factorial times 2 factorial. What do you get? 6? It's 6. So to put that into the calculator, let me bring up the calculator here. That's the graph. There we go. I want 4 factorial. So that's down here. Okay, and then I'm going to divide by 2 factorial times 2 factorial. So I need parentheses so that everything that I have in the denominator stays in the denominator. And now I can type in the 2 factorial times 2 factorial. And then I can hit enter and I get 6. Okay? Yeah, if just always check what you have sitting here and make sure that that 2 factorial that's supposed to be in the denominator didn't get booted off to the side. That's how you're going to get 24 instead of 6. Okay? So the other thing you could do is use the fraction template, which is if you press Control Divide, that's the little box over box above the division thing. If I press Control Divide, that gives me the fraction template. And then I can work in the numerator, put my 4 factorial, and then I can move down to the denominator and put 2 factorial, 2 factorial. Okay? That might be a better way to go. So let's go ahead and practice with those other 4 problems. So I want to show you what the factorial stuff is doing as we kind of work our way across. This 4 combination 2 formula here has 4 factorial in the top. So that's 4 times 3 times 2 times 1. Divided by 2 factorial, 2 times 1, times 2 factorial, 2 times 1. If I write that out like that, then I can see that what's happening here is I'm losing those 2s, they're a fancy 1. I'm losing those 1s, it's a fancy 1 anyway. And then I wind up with 4 times 3 on top, 2 times 1 on the bottom. 12 divided by 2 is 6. So it's not really a mystery what's happening here with the numbers as we enter these things into our calculator. So 6p3 is going to be 6 factorial divided by 6 minus 3 factorial, which is 3 factorial. When you type that into your calculator, you get your answer. But if you keep in the back of your mind, this is actually 6 times 4 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. The 3 times 2 times 1 parts go away, and you're just left with 6 times 5 times 4. What do we get for that one? 120. So with that extra r factorial in the denominator, you're winding up dividing by more stuff. And that is why, in this formula, we wind up with, if we were to do, let's see, did I have one up here? No, I didn't. If we were to do 6p3 and then 6c3, which number would wind up being larger? The 6p3, because we don't have that extra division of more numbers down in the bottom. The combination is going to wind up being smaller. And that's because of those repeated values. As soon as you start saying that the combinations, the repeated values don't matter, like if I get the Gordettos and then the goldfish, or if I get the goldfish and the Gordettos, that is the same result. But I got them in a different order, and that's okay. So once those orders start to matter, then that's going to decrease, or that's going to increase the number of permutations. All right, I have one more thing for you. I think you're going to appreciate it. The question you're about to ask me is what?
Is there a permutation or combination notation for a function on the calculator?
Yes, and there is. So you can use the NPR and the NCR formulas on the calculator. The calculator has that function built into it. Ours is in a particular spot. If you have a graphing calculator or a scientific calculator, those will also do it. It's just going to be a different spot, and you have to learn how to enter it in correctly. Ours will be found if you press Menu, and what do you see under the menu? What else do you see besides algebra? So which one do I probably want? Probability. So option 5, and then there's your factorial, and also permutations and combinations. So let's go ahead and pick permutations, and we'll do that 5p3 problem. As soon as I select permutations, it gives me NPR in parentheses. To do this on this calculator, you want to type in the n, so the left number, which was 5, and then comma. The comma is next to the O underneath the pi at the bottom left corner of our calculators. And then the R, which in this case was 3, and you can press enter and it gives you your 60. So you no longer have to type in the entire formula. You can just use that. And by the way, if you want, you can even type in the letters NPR parentheses, and it will revert to this. You don't even have to go to the menu. But it's like menu 5, 2, or 3. It's pretty simple to get there anyway. It's still 3 button pushes. So that's the route I would go. If we want 6C1, then we're going to go with a combination. We have NCR on the calculator, so I'm going to type 6, 1 and hit enter, and there's only 6 ways that one can occur. So that's the whole section for you. You can do the entire assignment now.